So hopefully you had a chance between the last video and this one to try number 31. So let's work through it together. So we are trying to convert that decimal into degrees, minutes, and seconds. So the whole number is going to give us the number of degrees. We have 18 whole degrees. Now we've got to convert that to 0.255 into minutes and seconds. So we're going to start by converting it into minutes. I know that that's going to be equal to x over 60. I'm trying to figure out what part of 60 is going to be the number of minutes. That x is going to be the number of minutes. So if I multiply both sides by 0.255, if I multiply both sides by 60, I'm going to get 15.3. So that whole number is going to tell me the minutes. So now we've taken that decimal and we've converted this into minutes. So now I've got to convert this, that 0.3, into seconds. I know there are 60 seconds and 1 minute. So I'm going to take 0.3, multiply it by 60. I'm solving that little mini equation that I set up there. And that's going to give me 18 seconds. So there's our conversion. Now, when we talk about how do we measure an angle, there's two ways we can think about it. We can think about it in terms of degrees, which is probably what we're used to seeing, but we can also convert things between radians. And the way we convert back and forth between the two is if we have degrees and we want to convert into radians, we can think about 180 over pi, because degrees are in degree. So you see the little symbol that we're using right there. And those are going to cancel. So for instance, let's look at number 35. In number 35, we have 30 degrees, and we want to convert that into radians. So we're going to multiply by the equivalency. 180 degrees is equal to pi radians. So the 180 is going to go on the bottom so that degrees cancel. And then the pi's got to go on top. That's why we're multiplying by pi over 180 when we want to convert to radians. So I'm going to get 30 degrees pi over 180 degrees. And you see how those degrees are going to cancel. Then we're going to reduce these fractions also. 30 goes into 186 times. So this is equivalent to pi over 6. We could do the same thing for number 37. We've got 240 degrees. We want to convert to radians. Our conversion factor is pi over 180. So I've got 240 degrees pi over 180 degrees. And you see how the degrees are going to cancel. Now we've just got to reduce our fraction here. So 240 pi over 180 pi reduces to 24 pi over 18. And we can reduce that even further. 3 goes into both of those. 3 goes into 24 8 times. 3 goes into 18 6 times, and we can reduce even further. Two goes into both. So that's equivalent to 4 pi over 3. Okay, it even works for negative angles. Take a minute, pause the video, try number 43. So in 43, we have negative 135 degrees. We want to convert to radians. We're going to multiply by pi over 180 degrees. You see the degrees are going to reduce. And that's going to reduce to negative 3 pi over 4. So there's our equivalency. Now, suppose we want to go the other way. We want to convert from radians to degrees. To convert from radians to degrees, we're going to multiply by 180 over pi. So let's look at an example. Let's look at number 48. 48, we have 5 pi over 6. We want to convert to degrees, so we want the degrees to be on top. And we know 180 degrees is equivalent to pi radians. So let's do some reducing. You can see the pi's are going to cancel. And 6 actually goes into 180, 30 times? So 5 times 30 degrees is 150 degrees. Okay, take a minute, pause the video, try number 54. 54 is going to work the same way. So we're going to have 5 pi over 12. And we are going to multiply by 180 degrees over pi. Because we want degrees, degrees has to be in the numerator. Okay, and that's going to cancel. Let's see if we can reduce anything else. 6 goes into 12 2 times. 6 goes into 180 30 times. So we have 5 times 30 is 150 over 2, which reduces to 75. You want to reduce as far as you can. Now, radians are nice because some of the formulas that we have are actually intended to be used with theta being the angle, measured in terms of radians. So let's look at arc length. For a circle of radius r, a central angle of theta radians subtends an arc whose length s is s equals r theta. So here's what we're saying. We've got this circle here when they're talking about a central angle, they're talking about an angle that starts at the center and measures out. Okay, so here's the angle that we're talking about. The measurement they're looking at, the arc length, is this side here, S. What would be the measure of that arc that for that angle that cuts into that circle? And to measure that, we really have to have theta in terms of radians. That's going to be important. So let's look at an example. Number 87, they're asking us to find the arc length. In other words, how long is this segment here? It's not a line, it's an arc. So it's a little bit different to measure than something that we've measured before. So we're going to use our formula, S equals R theta. Our R is pi over 3. Our R is our radius, which is 2. Theta is pi over 3. So we're going to get 2 pi over 3, and that's going to be in terms of feet. Now, if we want to find the area of that pi piece, which is called a sector, the area is going to be 1/2 r squared theta. So for this guy, suppose we want to find that area. Maybe this is a Thanksgiving pie, and that's really big, right? Because it's 2 feet in diameter. In radius. And we want to know what would the area of that be. So area is going to be 1/2 r squared theta. So we're going to have 1/2 times 4 times pi over 3. So we're going to have an area, in this case, of 2 pi over 3 square feet. It just happens to be the same in this case, same number in this case. It does not always happen that way. That would be like the biggest pie piece ever, right?